Okay, welcome everyone to the June 19th OMR Architecture Meeting. Today we have one topic to discuss. So Gita Koblenz is going to take us through some new IL opcodes that she would like to introduce. So I will turn it over to Gita. Take us through those.
Thanks. Yeah. So not many opcodes. It's vector opcodes. First, I'll give some background. In OMR, we have a notion of vector operations. They're defined in the vector operations enum.
Sorry, Gita.
Yeah.
Sharing your screen, we're not seeing that anymore. I think that.
Yeah, I need to start over. Oh, okay.
Yep.
Sure. Oh.
There's nothing beyond there. It's just the construction.
Well, sorry, I think I lost my presentation. 1 second. Oh, almost there. Oh, yeah, okay. Can you see it now?
Yes. No. Yes.
Like.
Please go ahead.
New OMR vector operations. So first I'll give you background. OMR has vector operations defined in vector operations.enum, and they used to create vector opcodes during JIT compilation. Essentially, they create an enum at when JIT is compiling, and this all actual opcodes, they're like all other opcodes in OMR. They're like strongly typed, and they have encoded like source type, like for example operation on float vectors, and if necessary result type, like for example if you have like compare, like say for example conversion operation, like say vector float 128 to like int 128, then you have two types encoded into the opcode, and some of them they all called like vector operations, but some they actually operate on masks, but they're very similar to vectors. And when masks are created, they usually created say like from loading from Boolean array or from one Boolean value, and in that case it's just whatever is the presentation of Boolean value in a particular language. For example, in Java it's a 0 or 1, but internally mask representation depends on the platform. For example, if platform has dedicated mask registers, we will use those registers. If not, then we'll use like platform, consumer can use vector registers. Then lanes containing in each lane will be like zeros or all ones. It's just convenient. For example, on power, that's just how like all kind of like Boolean operations are done. They're like bitwise, so masks are like -1. So there is a bit of a difference, right? What is input and what is actual internal representation. This is just some background. And then this new, and we have already many mask opcodes, just some were missing. So I wanted to add them, propose to adding them, and one non-mask opcode. So first one is, I think, relatively basic opcode is msplats opcode. It's actually similar to vsplats opcode, and it takes one child and places its value into all lanes of the resulting mask. Child contains Boolean value in the language representation, and resulting mask is internal OMR representation, mask register or a vector register. So it's very similar to vsplats, but for masks. But since we have, typed IL, we want specifically for mask know that it returns mask type. So should I go through all opcodes, or we can like discuss one at a time?
I mean, I guess if people have specific questions about each, you can stop. So I'm just one question here. What is the type of what is the OMR type of a mask?
Yeah, we have like TR
The is that what
mask
the
types.
VMR is? Oh, okay, never mind. I
We
think I
have
get it.
vector types, we have all the scalar types, then they followed like in TR data types, scalar types, then we have vector types, all combinations of length and element types. They're just not like explicit enums, and
So the
then they're
mask.
followed by mask types. It's like special type, yeah.
Okay, so the mask type doesn't actually materialize itself until the back end, until you know what the capabilities of that architecture are.
No,
Like if
type
you have
is always the same. Like for example, mask, what is like TR mask with like 4 elements, like say one, oh no, it goes by length, right? 128 bit of ints, like meaning like 4 lanes. So it has length and lanes. And the internal representation is more like when it becomes a register, like when node, when in a coaching, I would say. Right, like we can evaluate it into, yeah, when we have evaluator, like inside evaluator, for example, in this case, msplots will take the Boolean value, I think we represent it as int, right? And then we'll place it into all, we have, for example, on power, there is a instruction xplots, and it will put, like say, that Boolean value 0, 1 into all lanes. But through IL, there is a type, like mask type. It will look like mask type, right? So, yeah, and often we need to say we need a mask of all true values or of all false values, and then it's maybe later in optimizer, maybe in simplifier, we'll say if we can prove, we can see that it's a constant child in all ones, and we ending mask with something, we can remove that end, like it's kind of easy to optimize, see that mask contains of all elements, the same elements. Okay, so maybe let's move to next one. So M and M, yeah, any
I
question?
have a question about input language representation here.
Yeah,
So,
sure.
I mean, I understand that this may be motivated by like trying not to have Java dictate everything, but it seems to me that something like, you know, 1 means true and 0 means false is about as standard as possible in general. But my concern is really that if we don't nail that down, we're going to be in a situation where the semantics of the vector, or sorry, the mask splats operation will depend on what source language we're supposedly compiling, and that I don't think that that's a good way to go personally, but I just wanted to raise that.
Not sure, because we want to make it general, right? We can say whatever true or false, like for example, we loaded some value from array, Boolean array, whatever its value is, just load it into mask the way you want to load it. Like I cannot dictate representation of Boolean values, right? At this,
And
in this
no, like
proposal.
you can't dictate the representation that any particular language might use for
Right,
Boolean
yeah.
values. But I think that we should dictate the representation that we expect
For this opcode.
for, right, because otherwise, what is the semantics of the opcode? Well, it depends on you know, now somebody implements a different language that makes an unorthodox choice and swaps 0 and 1, and suddenly the semantics of this opcode are different for that project, right? I think it would be hard to reason about it
sure. Like, of course, we can say it should be just 0, 1, but I'm just wondering impact on other languages. Then they will have to do extra work to make them 0, 1. It just the way, if you look at it as a true or false, right? True or false, like, but
right.
I kind
But
of like.
I think that if a language wants to use a different representation than 0 or 1, that they have opted into extra work in many ways already.
They have two options, right? The first
Right.
option is to map everything into 0 and 1 as is defined in OMR, or they can define their own opcode and their own extension of the compiler that's specific to their language and do whatever the hell they want. So I agree with Devin. I mean, I think the opcodes in OMR need to have a definition in OMR that you can rely upon. Otherwise, like, what's the optimizer going to do? Right? Like, you don't want a language that can define true as false and false as like reverse them or something silly like that. That would be weird. To be able to tolerate that throughout the whole optimizer and get everything right in every scenario, I don't think it's reasonable.
I see. Okay, sure. It's interesting. Yeah.
I mean, if we had examples of lots of languages, like some of them wanted to do false as 0 and some of them wanted to do true as 0, then we could have a different discussion maybe. But I think 0 is 1 is true is a reasonable line in the sand to draw.
Yeah, like it would be kind of like if we said, well, the semantics of the integer or opcode depend on what language you're compiling.
I see. Okay, sure. Yeah, we can. It's easy. Yeah, we can sort of be more specific. Yeah. So I will change. Description.
Just to add, so I just wanted to make one point. It's just that we have an existing opcode that can convert a long bit mask into a mask. So that's an alternative that can do the same operation.
It's not exactly the same. I disagree. Basically, I think what you're saying is that we can encode, like knowing here we have opcode tells us that we need to take one value and put it in the same value into all lanes of mask. We can essentially encode it into long, which will hide the fact that all elements of mask have the same value. You're suggesting to use more general opcode for that, which loses information, right? We'll need to create trees to create a long first, all kind of arithmetic operations, then convert long to, then have opcode long to mask, and then on platforms that only use like really splat operation, converted long, somehow detect that all elements are the same and use splat operations. So I think it's overcomplicated. This opcode has very simple semantics. The fact that it can be expressed through much more complex opcode, I don't think it means that we should not have simpler opcode with simpler semantics.
Is the choice of a long for the mask a sort of a language specific thing? Like,
no, I think so. I just no.
Some implementation wanted to use a long for their mask rather than the more generic thing.
No, I think this one is less generic, right? Like you can always, if platform needs long to populate mask, it can always create it long, right?
I know. I'm just trying to understand. I mean, so if you were thinking of it in terms of a long, would that mean that a lot of these other mask sort of operations would have to change, or would you just have to know that, oh, my mask is really a long, so everywhere where I have an M and or an M or, I would just do long operation?
No, it's different. That's, you see, that's confusing. It's not that we want to make masks long. I think what Brad was saying is we're still gonna have masks, but in order to populate mask, right? One thing is to say, okay, I want all elements to be false or true, or some variable, right? Another way to say I have a long in which each bit represents lane in a mask.
Oh, I get
We
it.
have such opcodes, so we create more general representation of the mask in the form of long, and then we populate mask, and we have opcode for that, like it's called long bits to mask. But when you create long out of single value, you lose information that all bits are the same. So we just happen to have opcode that given a long, and each bit in that long represents a mask. Maybe it's convenient for some codegens that have masks for dedicated mask registers, but still you're losing information that all elements are the same by using that opcode. Long bits to mask.
In principle, that's just a flag that you could also represent that information as a flag on the that you happen to know that all the bits are one or true because that's where it came from. I mean, in principle,
but we don't know. Yeah, it can be variable too. We don't know. It can be variable too. It's just the fact that all elements are the same.
Right.
It's very similar.
In case where you'd be using an M-splat-S, you could also have, you probably know enough to be able to set a flag on the, I'm not suggesting this is an alternative, I'm just trying to explore the trade-off between different approaches. So in principle, you could also have you could also set a flag on the result to say, and I know all of these things are one, so that when you see this as the convert the long to, or whatever the operation is to convert the expanded splatted value to a mask register, it knows that they're all one or they're all zero, and right.
So you need 3 flags. You need one flag saying it's all zeros, another flag all ones, and another one just all the same. But also there's overhead of creating that long value. Like for some, it's not necessary. For some platforms, it's absolutely not necessary. We will have spent time creating that long value. We will carry it through the whole IL. There's like all kind of arithmetics needs to be done to create that long value. And then for many platforms in CodeGen, we would need to kind of like decode that value. Like,
so is there a similar kind of inefficiency for other platforms that don't use mask registers where they would have to do this M-splat thing, which would create a, if they had multiple M-splats, they'd all have to create their own longs.
But it's maybe in the lowering trees and tree lowerings we can do it. But through optimizer, it's nicer to carry simpler operation, right? And if platforms needs more work to expand it, do it in a tree lowering.
So I guess it seems like the main reason to try to avoid just using the conversion from long is that it's the complexity of the tree involved that we would need to compute what the long input should be.
Yeah,
because then you have to recognize that tree. You have to maybe special case it in CodeGen and stuff.
Exactly. Long tree pass through the whole. Instead of seeing just one value, we're gonna see like add, subtract, whatever, like shift in optimizer through the whole optimizer. We're gonna see long tree. Just and constantly, like all optimizations we need to know, like, oh, let's analyze that pattern to detect that it's just one value. In fact, like
right, okay.
It's just much more complicated. One thing is to say this is one value and all lanes are the same, use that value, similar to vector plots, versus having a long tree, like 3-level tree at least, and then telling all optimization that this pattern can end up in like just saying that all elements are the same.
Okay. So not necessarily to suggest that we should do it this way, but I think that if we're starting from a 0 or a 1, if we know that we have a 0 or a 1, then broadcasting that to all of the bits is just negation. So
if we know if we decide to only 0 or 1.
Right, and I guess like that, deciding whether it should be only 0 or 1 is another thing, right? I mean, I guess like you
could
distinguish 0 non-zero, or you could require it to be 0 1 for v-splats. But I guess the thing is that even if it's that simple to broadcast to all of along, you would still have to know, you'd have to preserve the information that we know that it's strictly 0 or 1.
Exactly. We need to add 3 additional flags. Is it
Yeah.
like I don't think it's. I'm not sure what's the reason to do that. If you can add just one simple opcode with very simple semantics, I think.
Okay.
Yeah.
Well, it's a simpler tree you'll have to look at, right? Like if you want to know if it's a 0 or a 1, you still have to look at the child to see what the value is to know that it's all zeros or all ones. That's the same. It's just one more tree removed if you do it with a v-splat, right? Because the v-splat will have a child that's a 0 or a 1, and then that gets converted to. Again, I'm not arguing that we should do it this way. I'm just exploring the trade-off between the different ways of doing this, because this is an example where we already have, as Brad pointed out, a way of doing this, sort of, which has some disadvantages. And you're proposing that we add another opcode which does it differently.
No. I think it's not different. It's simply, does it much simpler, I think. Much simpler. Like we're losing information and while splitting into long, like creating long, we're creating new trees in IL, trees more complicated. And then we need flags that sort of indicate what it was originally, like I think.
Well, so in practical terms, the only operation that generates this would pass either a 0 or a -1 into the intrinsic call.
Why do you say so? Why do you think so? Sorry. In which practical terms?
So it's only called in one particular function, which is the mask all function. And that calls an intrinsic, which passes either 0 or -1 based on the Boolean input.
No, first of all, we are talking specifically about Java case. We are talking about all consumers of OMR right now. The fact that in Java library currently somebody passes 0 or 1, I don't think should affect this design. It's OMR, right? It should be not only for Java. There will be many more other consumers.
Well, we're talking specifically about the long conversion operation, right? That opcode already exists and it has a well-defined behavior. I suppose if you wanted to do something similar in another language, they would have to handle that however they generate their trees. I mean, maybe it'd be more useful for another language to have an additional opcode, but I don't know if there's any real demand for that. This is kind of driven really by the vector API only.
No, I don't think we should assume that. Like, I think all of this opcode we're proposing, they should be, we assume that will be other consumers. And vector API can change too. It can change. It can pass something else. Even now, by the way, it doesn't pass 0 or 1. It passes ternary expression. If you look carefully at the library, it doesn't pass 0, 1. It passes an expression.
Right, but that will be simplified to 0 or -1.
It might not be simplified. You cannot assume it will be simplified. If library passes expression, you don't know what it's going to be. Maybe simplifier is disabled or something.
Okay, I
function
think
was
getting
not inline.
Bogged down in whether whether we're seeing a constant in the source code of some Java library
and
right
some
now. This
specific
is not,
application.
and I think it's really relevant.
Yes, I think it's,
it's what should matter about the value coming into this is what value it is allowed to be at runtime, and whether it's coming from this kind of expression or that kind of expression in source code, it doesn't matter.
Exactly, yeah. And I think we agree to limit it to 0, 1, but still I think we're kind of discussing that, right? But even if you assume that only 0 and 1 can be passed, it can be variable. It doesn't have to be constant, of course.
Right. Okay, well, I guess I'll just say that I think that msplats is at least it better captures the intention of what's trying to go on, or what operation is trying to be enacted by the program. Right, we have an example apparently where the vector API in Java is an example of a use for such an operation where, regardless of how it's implemented internally, this is something that some programs apparently want to express, and this operation would preserve that expression of broadcasting a singular value to all lanes.
Yes, I am completely
in a way that's
agree.
very transparent.
Exactly.
Rather than having to try to reverse engineer it from,
exactly.
Okay, well, maybe there's a subtraction here and there's a sign extension, and is that allowed to be anything other than 0 or 1? And what can we figure out about what this does?
Exactly.
It should be more transparent about what it's doing.
Yeah, I completely agree. Yeah, it's just very simple opcode, very simple semantics, I think. Yeah. Okay, thanks. Yeah, we can get back to it. We have some time, so maybe let's move on to M and M or M XOR. Again, it's like we have the same operations for vectors. We just, since we have typed IL, and these operations are allowed on masks with kind of simple, sort of relatively obvious semantics, we need this opcode. So they used, again, like if we sort of need some precedent, it's vector API definitely uses it. I'm pretty sure other consumers will need it. So it's logical operations on mask, to mask children in internal representation, and the result is also an internal representation. So this three commonly used in vector API at least. And another opcode is VUConf. We have VConf, and this is the one that has, I mentioned, two types, source and result. And VUConf, again, motivated by Java, but maybe other consumers would need it too. So it interprets integer values as unsigned. It's essentially the 0 extension, but we call it like uconf because we interpret integer lanes as unsigned. So it's similar to vconf, but has limitation that children has to be have integral elements. And but after that, yeah, they will be interpreted as unsigned, but result can be whatever we have, like result type can be float or any other type. So it just means that interpret integral elements as unsigned. So any questions about those others that we didn't discuss yet? All right, so I guess then they approved ECHO. I hope we can approve all of them.
Well,
Not yet?
oh no, I don't know if I'm willing to say yes at the moment. Maybe others are. I want to think about some of these a bit, but sorry, I'm just trying to think of that VU comp one at the moment. Scope description.
Yeah, sure. Yeah, this one a little bit less trivial, I would say.
So interprets a child's lanes as unsigned integers. So
if it is an integral type, like for example, it can be like vector of shorts, but it's zero extent. It assumes that it's unsigned. Right now in Java, I should say, it doesn't allow, for example, resulting type to be float. Essentially, just means resulting type is also integral type. That is, and it's like zero extension. Basically, it does zero extension.
Yeah. Okay. Okay. I mean, just my. So I think I'm okay with anything like mand, mor, mxor, and even view conv. Msplats, there seems to have been some alternate opinions expressed on that. Maybe what I'd like to ask people to do is to document their concerns in the PR that Kita has so that we can give that some additional consideration and then make the right decision on how we want to go forward with that. I mean, certainly not all committers are part of this group at the moment, but I think we'd like to get some documentation down in that PR, pros and cons for what people think, and then we can go from there.
Yeah, sounds good. Yeah. The only
So
thing
for those
we
that
kind of
expressed opinions, Devin, Brad, Mark, who's just left the room, that sound reasonable? You can drop your thoughts in that PR.
So I don't think I actually have a concern. I was thinking about what it might look like to try to just represent this using the conversion from long that exists. But I don't know. It seemed to be at once simpler than you might initially think, but also limited in expression of sort of the intent of the operation, because you would have to preserve additional information about the input value, or you would have to do extra operations to guarantee input value that is in, say it's only a 0 or 1. So maybe you would have to mask, or you'd have to do a comparison, or things that are going to output strictly 0 or 1. And then you would be carrying around these extra trees, or you'd be carrying around some extra flag that indicates this is strictly 0, 1, or something when you're trying to recognize something that looks like this operation. So I think it seems like a good idea. So I won't be expressing concerns.
Yeah, but if somebody expresses concerns, somebody needs to express support as well. And don't forget, right, like we encoded information too long. That's extra work, right? And then we need to kind of decode it. Yeah, like when we in evaluator, right? So it's also extra work for platforms which don't only have splats instruction. They don't have like anything to directly convert long to mask.
Can I ask a naive question? So the choice of a long here, is that because there's a the maximum number of lanes is 64? Is that the assumption? And that's why you can use a long?
Oh, it's a good question. Yeah, it's just because no, I think the reason is just because we already happen to have this opcode m long bits to mask, which you're right might not be sufficient in the future
Well,
if
I'm
vector
thinking
has
more
more than
about
64-bit vectors.
yeah.
Yeah,
So I'm
that's good.
thinking
That's
about
good point. Yeah.
the extensions on ARM that might be coming. I mean, even looking 3 to 5 years down the road, which isn't all that long. I mean, 64 lanes works for AVX 512 right now.
Yes.
But
Yeah.
would it work for the 1024
Exactly.
bits
Very good
at
point.
ARM?
Very good point. Yeah.
I mean, I don't want to overly future-proof it, but maybe just something to consider as part of the thinking.
Right. Yeah. Yeah. I think that the bit opcode m long bits to mask it comes from vector API library has method create mask from long, and that's why we had that opcode.
Oh, that came from the Java Vector API.
Yes, yeah, it was motivated by that. Yeah, but Java vector API also has a method called mask all or something like, and it takes just one parameter like value that needs to be broadcasted, and it even has like an opcode called broadcast. When it uses that method, it creates intrinsic with specifically opcode called broadcast, which is kind of maps into splats. So hiding it by more under some much more complex operation kind of feels like sort of redundant, I think.
Okay, so I'll drop a message in the in one of the OMR Slack channels, just asking people to put any thoughts that they might have into the msplats. I don't think you actually list the name of the number that actually it's in the oh, I don't have that. I don't have that. Just listing the PR number that you have should be easy to find, and then we'll collect some input on that and then make a decision from that after considering that. And
Yeah,
same
hope,
thing with the other ones too, right? I don't think anybody expressed any opinion one way or the other for the others, but
mhm.
we're gonna make sure that all ideas are considered.
So you're gonna put a note into Slack?
Yep, and I'd like to get
Okay.
feedback from this within the next few days. I don't want this to drag on too long. I know
Yeah,
want
yeah.
to
Hopefully,
get
yeah.
having some discussion. So prolonging this beyond, the next few days, I don't think is fair. So let's.
Yeah, thanks. Yeah. Yeah, relatively straightforward opcodes, I think.
Okay.
Okay.
All right. Any other discussion questions for Gita on this? Okay. If not, thanks, Gita, for presenting that. That's the only topic we had this week, and I'm going to cancel the one in 2 weeks because I don't think we'll have very many people here, which means our next meeting will be in 4 weeks. Right. Thanks, everyone. Bye.
Thanks. Bye.